So just to, because I forgot to record, we're talking about is implicit and explicit casting. Implicit is when we could add a smaller object or a smaller value or a smaller thing into a bigger box, into a bigger variable. And that's what we did here, where integer is smaller and we put it into this thing long, right? Which could have a higher number. And the L here is to represent that this value is not integer, it's actually a bigger number, right? So in this case, we're allowed to do implicit casting, such as making this value equal an integer, a smaller variable type, while this is illegal. If I didn't have this parentheses, this would give me an error saying, yeah, I need an integer, but you provided something much bigger. I needed a small screen, but you provided a door or a window or a chair. And it's too big. I can't put it in directly. And you could explicitly do it by casting it from the front, right? Now you're gonna ask, well, why do we even have this thing as implicit and explicit? Why doesn't it just always do it? Well, when we're trying to do something like this thing that requires explicit, it's because we're gonna lose part of this number, right? A good example of this would be, let me show you here. Let's do another casting. Let's say we have a double, big precision. And let's say it's 3.1, 2, 3, 4, 5, 6, 7, 8, 9, and we're gonna restart that. I don't know how much we could go there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say that's that. Then I have a float, and let's say I'm trying to bring that number in here. So bring big here, okay? Oops, that's big number. That's not correct. Big precision. You'll notice it's gonna give me an error. It's not automatically doing it, even though if we just add the words float inside, it will automatically cast it for us. Why isn't it doing it for us automatically? Is because it wants us to be notified. It wants us to confirm that we know what we're doing, that we know that we're gonna lose part of this number. So if we print out to the screen again and we say, let's say big precision over here equals, actually that, so 1 second. Big precision over here, let's say float big, is that we understand that we're gonna lose a lot of that precision. If we weren't to lose anything, if there was no loss at all, it would automatically do an implicit cast for us, such as here. But if we're gonna lose values, we're gonna have a different end result. This is the moment we need to use explicit casting. We need to mention to the compiler that we understand what we're doing, and this is the goal for this. Otherwise, it wouldn't care, it would do it everywhere. But this loss, again, could come down to millions of dollars for a financial company, and you need to for sure understand that that's happening. This is why the tool doesn't do it for you automatically. Any questions about explicit and implicit? No? So here I'm going to put implicit typecasting when you do not lose data. Something smaller into bigger. Okay? Explicit typecasting is when you know you are going to lose some data. And you need to mention, you need to explicitly say the type you want to cast to in front of the variable name. So this variable is going to be casted to this. Cool? So if no questions, let's move on to the next thing.
Sir? Yeah.
Yes, sir.
So where exactly we use these castings like in the real scenarios? Any example that you could give?
Um, Let me think about this. This would be so when you're sending values around to different functions, classes, and for some odd reason it reached those numbers, or you're trying to cast it. To be honest, I can't think of something right off the top of my head. Um, but you're gonna see this coming up here and there. Um, I really can't think of something right now. Hmm. Let me. I'm trying to think of something. Mm. I really can't think of an example that would be real world usage right away. But I'm telling you, you're gonna see it here and there. It's just, and you're gonna see it when we make our own types. You could also do implicit and explicit. Uh, but again, I can't think of any good reason to show you that, because here, even though we put, let's say, this smaller number into this bigger number and we lost values, it doesn't really tell you why you would even do that, right? So I don't have a example of a real world in this case. If you go Google this a bit, I'm pretty sure you'll find a few people that would give you a real world example. But in this case, as we don't have a real project going on, this doesn't really come in, right? And
Okay.
I can't think of anything right now. If I do, I'll post it inside Slack, or you could ask it there, and as soon as I do, I'll go and mention it.
That's
Yeah,
it.
yeah, no problem. And sorry, any other questions? Okay. The next thing we want to do is we want to get the user's input. So we had output. Actually, I didn't write it here. Let's go. Output. This was to print to the screen, and we needed to use something such as system.out.print. Whatever you want to put, you put it inside here. We also had system.out.println, which adds a new line at the end, right? We could also do the shortcut, which is SOT, shortcut for that. I got cat hair in my mouth. Now, we got the output. How about we get the input from the console? And again, these will differentiate depending on the system you are. It's not always you're going to be outputting to the console. You could be outputting to a 3D virtual world. You could be outputting to whatever. And the same goes for input. Input right now is going to be from the console, but you could get input from the microphone, from a camera, from 3D worlds, whatever it is. In our case, there's actually a few ways to do inputs, but the one we're going to use is this thing called scanner. So it's someone's code that enables us to get code. Actually, do I want to start this? Yeah, let's do it. Someone asked a question, so might as well. So scanner is someone's library, someone's who wrote, just like us, who wrote a bunch of classes, and now he distributed his code. So the first thing we need to do to use scanner for getting the user's input from the console or from anywhere is at the top of our page. In this case, for me, the top will be here. We need to start importing the scanner, which is inside java.util.scanner. Okay? This comes in with your JDK, so it's kind of already given to you. If you use someone else's code later on, you'll have to have that code somewhere in your project. But for now, inside the JDK, this comes in built in. So the first thing we need to do is import that code into our project. And this is important because we don't want to have our project bloated with a million stuff, right? So we don't want to have the JDK always with our applications. Otherwise, our application would be 100 megabyte every time, or a couple of gigs, or whatever the size is of the JDK. So what we want to do is we want to import what we need for our application right away. And then, let's go down here. We want to create the object scanner. We'll talk about objects in a bit. And what this guy is going to do, he's going to be the guy who's going to read the inputs from the user, and you're gonna see that in a second. So here we gotta tell it new scanner. We'll talk about this in a second. Where do you want it to scan? In this case, we want to grab the system.in. So the system in is connected right now to our console. So it's gonna scan that and put in the values. If we wanted to, inside this parentheses, we could have said, you know, go grab me this file, and we're gonna read that file. In this case, we're grabbing the user's inputs. Give me 1 second, just go grab some water. Now, when we grab this the user's data, we need to kind of notify the user on the screen. So the first thing we should actually do is to system.out, not println, but print what is your name, and I put a colon and a space like this. Why do we need to do this and not just directly? Well, if the user doesn't understand that he has to input something, well, your program fails right there, right? So the first thing we want to do is tell the user, hey, I'm expecting your name, and then we want to use that scanner to get that name. So we're going to use scanner, the variable we just created, scanner, dot, we're going to talk about this a bit later, dot, and now we want to get the next value there. So this keyword, I don't really like the naming style, but whatever. You're going to use next. And what next does, this is important to read, we're going to talk about this a bit later. It's going to return you a string. And notice that inside my Intellisense, this little thing that popped up, there's a lot of these functions that we see here, the names. So in this thing is returning our string. And the next big decimal is returning a big decimal. The next Boolean is returning a Boolean value, etc. Right? So when I do this next, this is gonna give me the value of a string. Actually, we should have done this a bit later, but it's fine. So it's gonna return us, it's gonna give us a value. So this value is of type string, so we could store it, user name here, and that would be equal to that scanner.next. Does that make sense to everyone? Did I go too fast? I'll re-explain as we learn about functions and whatnot, as I review functions and whatnot. But for us to get the user's input, in this case, we want to get the next string. We would just type in next with a parentheses. This is a function call. We'll come back to this. And as soon as we do that, you'll notice that now we could print out the username. And if we run it, you'll notice the computer, again, remember it only does one line at a time. So the computer is currently stuck at line 80, where the scanner is waiting for the user to type in a name. So I say Reza, and I press enter. As soon as I press enter, it goes to line 81, and he prints that variable that I stored that value from the scanner. And if you look on the console, you'll notice that my input, the user input, is in green, while the user's output, while the computer, the program's output is in white. Any questions?
Sir, can you repeat it again, sir? I didn't get.
So to get the user's input, we need to use this thing called the scanner. Now, the scanner is someone's code. They already wrote it. Actually, if you hold down control, you could click on scanner, and you could go ahead and read the code for scanner, and it's a lot of stuff in there. Okay? One thing is, we don't want to read every code we use. We kind of want to believe and it's going to do what it's supposed to do. That's why we come back to our goals. We want our code to be readable, so functions name, variable names, precise, to the point. And we want to separate the concern. So our scanner is only going to scan and give back us our value and nothing else. Okay? So in this case, we're using someone's code which is going to read the system in. In this case, the system in, it means our console. And it's going to create this object, okay? But before we could use this object, make sure you have the import at the top, right? If we erase this, you'll notice it's going to give us an error. Put your mouse over the error, you'll see it's going to say cannot resolve symbol scanner. It doesn't know what scanner is. Okay, so if we come back down here, I muted you, Anjan, okay? If we come back here, the scanner in this case is going to read from our console. So the first thing I do on line 79, I write to the screen, what is your name? Right? It's line 79. It's not a print ln. Line 80. Remember, your computer is stupid. It goes from top to bottom, one line at a time. So one command at a time, one statement. On line 80, I create a variable of type string, which is username, and I initialize it to the value of scanner.next. So this is a function that's built into Scanner, which would detect what's being written inside my console. And as soon as the user presses enter, this is going to return the value that was there. So Reza was entered, it stored it inside username, and that's the value being shown. So here I could say value shown is, let's say I'm doing a string concatenation. We'll talk about this in a second. And here I write, let's say happy, and I press enter. Value shown is happy. So this variable right now contains the user's input, and we can manage it, adjust it, etc. Cool? Does that make sense?
Yes, thank you.
Again, stop me anytime. Sorry, my cat wants attention. So the scanner is useful, but there's a lot of trouble with it. One thing is you need to always know what the user is going to type in. So you need to mention to the user what the type is, right? So what is your name? We're expecting a string. What if I was to say, let's go print, what is your age? And in this case, I don't want to put his age into a type string. There's no reason for that. I want to put it inside of a type of age, right? We already actually created age at the top. So we're just going to say age equals to scanner. But this time, .next, if I use that, it's going to give me an error. If I put my mouse over it, it says we're requiring an integer because age is of type int. But scanner.next is providing a string. So this is not good. So here we have to mention that the next value that I'm getting has to be a integer. Does that make sense? So let's say value shown here. I'm going to bring that down. And I'm going to say his username is of age. Okay, this is string concatenation. It's basically adding multiple strings one after the next together. And let's press play. So what is your name? I would put Reza. What is your age? I would put, let's say, 59. And then we get Reza is of age 59. Any questions? So what string does, it's basically taking the spaces into account. So this is, how would I say it? It processes the value entered, and it's going to take into account spaces and new lines. And this is really important. What I mean by this is, let's say if you had, how would I say this? So let's say, okay, so let's rerun the code actually. This might make more sense if we just rerun it. So this time, what is your name? I would say Reza, Reza of the family, blah, blah, blah. Okay? Press enter, and you'll notice that it's getting an exception. Why is that? It's because this reza of the family blah 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 is going inside this thing called the cache memory, inside this temporary memory where it's being divided and used. And what's happening is when you call scanner.next, it's gonna go ahead and take the first thing that's separated by either a space or by a new line. The new line is at the end, but the space, you could see it, is right here. So Reza will go inside username, and then it's writing what is your age. And it notices when you're doing next int, it's going to grab the next part after your name. And in this case, you'll notice that it's OF and not a integer number. So in this part, you see it thrown an exception where it says input mismatch exception. So we have an error at line 82, right? Everyone's with me? So
Sir, I didn't understand. How did that happen?
this is because when you call the next, it's gonna go grabs everything before a space or a new line, right? So if you notice inside the input of the user, he wrote Reza of the family blah blah blah. When you call the next, it actually only grabbed Reza, and of the family blah 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 stayed inside the cache memory. It stayed in that space, that temporary space. And the next time where you did next integer, well, you were expecting an integer, but it gave you a OF. Does that kind of make sense?
Yes.
Yes, sir. Yes.
Again, if you say yes, you don't need to mention it. I'm looking for more of the people that say no, so I could reiterate as many times as needed. So scanner is a bit dangerous where you need to know which one to use correctly and so on. So in this case, if I wanted to read the whole line and make that the whole family thing, rather than next, I would need to use this other thing called next line. So now it would get everything until it finds a new line. So now if I run it again, what is your name is going to say Reza of the family blah blah whatever. And you'll notice there's no errors because this time it's not going towards the next space, right? It's going towards the next line. That's why the next line is there. Does that make sense? And again, if I put, when I'm expecting an integer and if I put a different type of character, I'll get an exception. And I'll show you how to deal with exceptions a bit later. Okay, so the type mismatch, we can't have that. It has to be the specified type from the user. Any questions? So I'm going to comment this. And over here, we'll put next line. So here it grabs everything until the new line. So now, one of the questions I got from one of you, I don't remember who, is you said, I got a lot of words or characters and whatnot, and I want to go through it as an array. And you could do that. So let's just do that. That's an off topic, but it's fine. So let's say, again, this let the user know. So we're going to do an S out. Enter some characters to store. Okay. And we have to mention the size. Remember that our arrays are fixed size, and this is called immutable things, and we'll talk about that in a bit. Enter some characters to store and of size, or let's just say enter characters. Okay. Max, I think we said 4. And we'll enter it in that array we already created. And inside that, we're gonna get the user's input. So again, we're gonna do scanner, but this time we're not gonna get a whole word and we're not gonna get a whole line. This time we wanna get a character. So let's type in next, and we notice that there is no character. So character by itself is not possible. Well, there's ways to go around it. We could even deal with the bytes, but let's see if we get the word. Okay, so if you want to store it into an array for some reason, it's not the best thing to do, but let's say string, temporary string, I don't know, let's just get at it, and we're gonna create a for loop. Actually, you know what? I'm going off topic too much. You know what? I will come back to this later. Just remind me, because I'm jumping ahead, and I already doing scanner was ahead of my thing. Anyway, we'll come back to this. Okay. Any other questions for scanner? Okay, so that's good. So a couple things to remember for scanner. We need to first import the code for scanner. And again, depending on the language you go, you'll be something different. You were in C++, that was the CN. You might have used something else as well. And then we needed to initialize the variable scanner. We'll talk about this a bit later. This is creating a new object. And then we needed to call a function of that object, which was the next line or the next integer or the next. Depending which one we use, we need to understand what we're expecting and whatnot. Now, something I want you to remember about this IDE is if you put your cursor on one or something and you do Control Q, so put your cursor here and hold down Control and press Q, you'll get the information thing. The Intellisense will give you information about that function. Here you could read what it says, what it does. You could see what it returns. The int scanned from the input. This is for the next int. And what it could throw. These are errors that could happen. And this is important to know because we want to deal with the issue where he's entering age, but he's entering the incorrect age. Okay, we'll talk about these types of errors in a bit. So this is Control Q. You could also hold down Control and everything becomes a link. So we could go see that function and how that function has been written. So if I click this, you'll notice that this function is actually calling a different function. And inside this function, this is how it's doing it. Okay, we don't really care for this, but I find it interesting that you could go and read something, maybe further your knowledge, or maybe try to understand how they went at it, and so forth. Cool. So that is for scanner. Actually, what did we write up top? Someone's code. We need to import it. We need to initialize it. Initialize it with the input stream that we want. In this case is system.in. And then we need to call the functions for the appropriate return, like what we're expecting. Such as, what do we have? We have next for a word. So this is string. Next line for a whole line. Next int for an integer. And it keeps on going, right? I'm not going to mention every functions there. The Intellisense will actually provide you all that. Cool. Ooh, I'm getting tired. Let me grab some water. If you have a question, this is a good moment for that. Actually, I want to show you something nice while I'm taking a sip of water. You know, where we have these big numbers like this, something built into the IDE. I'm not sure if the whole Java has it now. It depends on the version you are. But in this IDE, it will automatically figure it out. Is when we read a big number like this, it's too hard to understand what it is. Is it a million, a billion, a Googleplex, or whatever number type it is? So something cool that you could do to help yourself out is they allow you to have underscores in the middle. And these underscores are there just for visual aspects. When it actually runs it, it does not see the underscores. The compiler, when it compiles your code into the computer code, will completely ignore these underscores. But if you look at the underscores, it cleaned up our code by a lot, right? It's a big difference when we come to this and we see, hey, it's 10 billion. I know it because, or I don't know it actually, that was a million. No, this is 100,000, million, billion. So it's easy to read than having 9 sets of zeros right beside each other and you have to go 1, 2, 3, 4, 5, 6 zeros. You know, it's too much work. So having these little underscores actually help us visually with our code. And again, this code should still run correctly. The underscores is just for human visual understanding. Cool? And you could put it anywhere you want actually. You could put it in here too. I like to divide them by sets of 3s. Right? And it becomes much easier to read your code and understand what's going on. But to be honest, the sets of 3 is up to you. If you wanted to, you could have a set of 5, a set of 4, whatever. The underscore, again, is just a visual signal, an idea of understanding how far or where we are in our numbering. So that's that. No questions. All right, next part. So the next part is, let's go back to arrays a bit. I'm going to go a bit further. Inside, there's 2 terms that we need to remember. Again, the output, input, actually, I'll try to make this into a clean thing. Function methods, variables. Okay. Inside variables, there are 2 types of variables. 2 major categories, let's say. And they're called mutable and immutable. Mutable is something that could change. A good example I like to tell my students is the word mutable is kind of like mutant, where change can happen. And this is important again, and you're gonna see why. And immutable is something where no change can happen, so not changeable at all. Did I mistake this? Short context action, typo. No, anyway, changeable? Yeah, there we go, I forgot the E. So immutable variables are such thing as string or as arrays, really all arrays, and a couple other things as example. So this is e.g. examples, strings, arrays, and so on. Mutable stuff are primitive type is a good example of mutable stuff. So integers, characters, etc., etc. All the primitive types. And what's so important about talking about mutable and immutable is, again, remember that there was a space assigned to our variables when they're declared, when they're initialized, when they're created. This amount of space given to us is restricted to where it is. And this is important because, actually, let me try this out. Annotation. So, so let's say this is the space in memory, okay? Sorry for my crookedness. And we're given a space inside that for our variable. Let's say our age here. But when we're given this space, well, there's a lot of other applications that are kind of running too, and all those applications are going to take their own space. So over here, right beside it is Chrome. And over here, there's something else. And over here, there's something else. So the computer can't just resize your thing and make it bigger or smaller. It's a fixed size. Now, because integers, characters, and all of those are given a fixed size of 4, even though they don't use all the bytes given to it, it's always changeable what's inside. But when you create an array, let me do a different color. When you create an array, so let's say an array of size 4 here. When you create an array, that array is immutable. Even though it's an array of integers, the integers inside could change value, but the array size cannot change. Because given that space, there's other applications running beside it that are using that memory. So if we want to resize it, we'll need to create a new string or a new array with that bigger size. Right? So we create a new one, 2, 3, whatever. So this new one, it's in a new location where there's nothing else there. And now because of that, it could have more values. And again, the sizes of the type is not going to be different. So here, this is an integer, and over here is integer as well, but it's an array of integers. So there is 4, let me go yellow, there is 4 bytes for each of those guys. Right? So over here, we're still giving it the size of 4 for each of them. The only difference is our array actually contains 1 extra 4 bytes. Okay? And this is important because, well, if we ever create an array, we can't resize it without doing a lot of work. And this is costly to the system. To be honest, you might never actually talk about mutables or immutables until you get to the work area, because our projects are too small or too simplistic that for us to matter. Does that kind of make sense? But it's something to note, and you're gonna see me, and we're gonna talk about immutables and mutables a bit further down the line, and this is something to remember in the back of our brains. This is something important because memory access is something costly. You might not notice it because you have super powered computers, but if you think about 20, 30 years ago, your current laptops would be considered as a supercomputer, right? As a super powerful computer that could do millions of statements and calculations and blah, blah, blah. Now, we'll come back to this again later. And again, sorry for my drawings. I don't have my tablet, and even with the tablet, it's not the best. But that's that. And again, you could always look up these terms and figure things out whenever you get there. Cool. Any questions on mutable and immutable? So actually, let's do an example. So in the immutable parts, given these arrays, if I wanted to resize this, I would actually need to create a new array. Actually, if I were to do name other way, this thing, and make it new size of character of 6 or 7, whatever, what would happen to all the values I had before? As I'm speaking to myself, I'm going to answer it. Basically, those values are going to get disappeared. Why? Because, again, we are in a different location in memory. So whatever we had in those are disappeared forever. So this is something to be a bit to watch out for, some silly mistake that we do at the beginning level. So for us to actually make this bigger while keeping our values, well, we first need to create a new character array, temporary array, right? And then we need to transfer all of those values into this one. Temp array at position 0 equals name other array at position 0. 3, 0, 1, 2, 3, right? And then we could go add more stuff to it. Let's say 4, P or whatever. And at the end of all of this, we could say, well, that name, the other, if we want the same variable to have the same values, we could just say name other way. Wow, that was a really bad name, eh? Name other way equals the temp array. Notice here I don't mention positions because we're making the arrays equal each other. In this case, we're doing something called reference pointing, okay? We'll talk about that as soon as we get to objects. Any questions before I move on? So again, we're doing this temporary array so we don't lose the previous data before we add an extra 1 or 2 or 3 or whatever. And now both arrays, the temp array and the name other way, would have the same values because they have the same, they're both equal to each other. Okay, so I think that's good for that. All right, next thing. Okay, so our stuff is getting big, but we're getting there. The next thing is we want to do is relational operators. Basically, if it's this, do that. If it's that, do that. It's basically if statements, right? So an if statement is the same as C++. You do if statement. Inside the parentheses, you'll put your question. Your question always need to give you back a Boolean answer. Boolean answer required. And by that, the question always needs to be a true or false answer. And this is important. You can't ask the computer, how does the sky feel like to you? You can't ask the computer, how do you feel, or really weird things where you cannot get a value back, or you cannot get a true or false answer back, right? You can't ask the computer, is outside cold for me or not? You have to be a bit more precise, where you say, is the temperature outside less than 0 degrees? And in that moment, you know if it's cold or if it's warm. So whatever question you ask inside the if statement, inside the parentheses, needs to give back a true or false. So in this case, we could use these things called relational operators, where we say if age is bigger than 5, do something, right? Now, if you wanted to, you could ask multiple questions into one to be a bit more precise. And you would use that with the end symbol, which basically says both sides of this end needs to be true for me to do whatever's inside this body, inside this parenthesis. Only do this if question is true. And both sides of it needs to be true. So if the sky is blue and I have my gym shorts and my ball, I could go play outside. If outside does not have the COVID virus and there's not a lot of people, I could go outside, right? Stuff like that. So if age is bigger than 5, and let's say age is also smaller than 10. So now we're looking for a range from 6 to 9 because we're saying less than. It can't be the same value. So there's a lot of these operations, and I'm not going to go through all of them. Here I'm going to list you, actually I'll list it at the top. So again, into not for variables, but let's say here, we're going to say, these are called, so if you need to Google it, these are called relational operators. And there's a bunch of them. So we have equal to compare, let's say A equal to B. So these are if they're the same. We got A does not, the exclamation mark is for not, equal to B. Is A greater than B? Is B, is A smaller than B? Actually, no. Equal to B. A not equal to B. And I know you guys know this, I'm just writing it just to make sure if someone didn't understood it or you forgot it or you feel it's a bit different. And then we get more than this, right? We still got a lot more. A is bigger than or equal to B. And the wording I put in is really important. Is greater than or equal to. So it could be either or. A is smaller than or equal to, right? And there's a few other operators that we're not going to use right now, and this is an important thing. And again, these relational operators is not just used for if statements. So let's go back down here. So even though we have relational operators here for asking a question, we could also be doing it to store a value. Relational operators. So I could say equals to if age is bigger than 5. And this would be still fine because age bigger than 5 is going to give you back a value of true or false, and that would be a Boolean. Right? So these questions are not always for if statements and loops and so forth, so on. Any questions? No? Okay. So we could join multiple relational operators like this with the and sign. We also have the or sign. And there is a precedence on which one comes first and which one comes second. This is the same as doing plus and negative, plus, minus, multiplication, division. So here we say if age is bigger than 5 and age is less than 10, or age, I don't know, let's say, I'm just using a random variable, or num equal 1. Right? And you'll notice here, here, notice that we're getting a little warning. It's saying, hey, condition num is always going to be false. Why? Because we give the value directly here. And the value doesn't get changed by the user. So it's giving us a little warning again. So this is basically saying useless code, right? And you could see. Cool? So, so there's that. So that's the and, that's the or. Now the order of which one goes first, it's usually the ends. However, I try and I would love it if you don't memorize that. And what you do is what you need to do first, you put parentheses around it. You could have as many parentheses as you want. In this case, oops. In this case, I'm gonna compare this or this, and then the result, I'm gonna compare it with this. Right? So that's an important task. What comes first, what comes second will determine if your question is true or false, and this is a big thing. Does anyone want me to go further on this? Okay. So that's something to remember. So I think that's good enough. Let's go a bit further inside the if statement. So we have if this happens. So if this question is true, we're gonna do the body in here. We could join this with another if statement, or we could keep them separate. So this would also run, right? So these two, if the age is bigger than 5, they would both run. Why? Because this is a separate question, and this is another question. So it's like as if I ask you, how are you today? You're good? Okay. How are you today? I ask you again. It's still fine, and you're still going to answer me, and I'm still going to get the value I want. And if that value is what I want, I'll do whatever's inside there. Okay? Now, you could make sure that your if statements only run one. So what I mean by this, only one direction of that statement will run. Either it's true, it's going to do this. If it's false, it's going to do this. To do that, we would add something called an else. So if this statement is true, do the body. If it's false, if it's false, do this body. And this is important because now we get the choice of going left or right, and based on that, we do something completely different. And we could make this more interesting by having multiple options. Now we don't have only left and right door, we have left, the second door, third door, fourth door, fifth door. And to do this, we would add these things where we call else if. And something to note about this, all of these ifs are connected together. Only one of them is gonna run. So we go top to bottom. Again, as always, top to bottom. First question is this. If this question is true, well then you could ignore all the other questions. We don't care. Now, if this question is not true, go to the second question, which in this case I don't have anything. Age, is it less than 5? Well, actually, let's say age, is it equal to 0? If that's true, it's gonna do this. And lastly, if both of this were false, it will automatically do whatever's in the else. And I hope you already learned this and you have a good mastery on it. If not, ask me and we'll make it a bit more fun. Now, the rule for if statements, you gotta understand, is that it starts with an if statement. It could have as many else ifs as you want, 0 to infinity. And at the end of it, it could have 0 to 1 else's. And if you reach the else, it will automatically do it because it's else. So if the sky is blue and I have my gyms, let's try this again. If the sky is blue and I have a basketball, go outside and play basketball. Else, if the sky is blue, in this case I don't have my basketball, go outside in the park. Else, so now the sky is not blue, I don't have my basketball, we're at the else, the last statement, there's no other options. Else, stay inside and just sleep, right? So that's an interesting thing. So I'm gonna put that at the top here. If statements starts by an if. You always need one of this, okay? Starts of the if. You could have else ifs afterwards. 0 to infinity of else ifs, as many as you want. And at the end, you could have a remaining else at the end. Cool? And all of these if else's are connected to one. So as soon as one of them is true, none of the other ones could run. So this is an important thing to grasp. So if you wanted to, you could have multiple ifs, or you could have a connected if, which is if else. Okay. Now, there's another thing inside C++ and Java that you might see elsewhere as well or not, is something called a switch statement. Now, a switch statement kind of cleans up your code a bit, but it's the same thing as an if. It actually doesn't exist when it gets translated to the computer code. There is no such thing as a switch. It's just basically if statements. And a switch, all you need to do, well, the first restriction with a switch is it could only have one thing being compared to a lot of variables. So in this case, I want to check for my age. And for each stages of my age, I want to do something. And this is interesting. So let's say for my age being 5 years old, I want to print out I am 5, right? And for each case that you create, so now here we're saying age, this is the same as saying age equal 5, right? For each cases that I'm done, I need to put in this term called break. And this is important. You're going to see why in a bit. So let's say I create another case. Let's say for when the age is 4. And in this one, I say I am 4. Oops. Forgot to put the quotes. I am 4. And in this case, I forget to break. Look what happens when I do this. Case 3. System.out. I am 3. And I do a break here. And we'll come back to this in a second. So let's say at the end of all of our code, we're going to set the age to 5. Run my application. What is your name? These are all previous code. What is your age? 33. Okay. So it reached the line 136. It set the age to 5. And now it's going through our switch. It checks with each case which one matches 5. As soon as it matches and it sees a break, it will come out. So it matched case 5. It printed out on 5. It broke. Now let's say I go to case 3. So now you should kind of understand what's going to be outputted before we reach that line. So Reza, and what is my age? Who cares? And it writes I am 3 and then breaks. Now what if we go to age equaling 4? And we press play. Notice that this time that the age equals 4, we have 2 issues. Well, not 2 issues, but 2 things that happen. One, it printed out I am 4. And it also printed out I am 3. Right? This is the cool thing and the bad thing about switches. What it allows you to do is it allows you to go through multiple cases until it reaches a break. And this could be useful when you have multiple cases that shows the same value. So give you an example would be, let's say for anything under 17. So this is not really good for doing bigger than or smaller than, but let's say I have case I am underaged. So the cool part is I could do something like this. And now I have 16, 17, 14, 13, 12, 11, 10. And you could do funky stuff. This is not the best example because it's stupid. It would have been better just doing an if statement less than, 18. But you could do funky stuff where any value that's one of these, we write or do the same thing. And if one of them is a bit more special, you could add an extra thing for that one. So let's say 17, almost there. So now it will print out almost there and I am underaged, right? Any questions? So in the end, this is an if statement. So if age equals 5, do that. If age equals 17 or age equals 16 or age 15, etc., do all of those. And we also have our special case, which is the else, which is shown by default. And as always, we need to kind of break it. Cool? And if you go in a higher level language, you could actually start making weird, funky stuff to this by having lesser than, bigger than, etc. The higher the level is, the more English it would look like, sound like, be able to do. But again, it will have more overhead, so it's going to be slower. You're going to have less accessibility, and so forth, so on. Yeah. Okay. No questions? I'm going to move on. So I'll put it at the top as always. If statements. Over here. Switch state. It's same as ifs. But with one variable. State So again, I leave you the terms so you could Google it and understand it better. And if you have any issues with any of these, you let me know and we'll go through it. Yeah. So now we could we've seen how to change values. We've seen how to do all that. There's two things inside that, which is called the increment and decrement, which you could do age plus plus, which is basically saying age equals age plus 1. You have this one, which is also saying age equals age plus 1. And then you'd be like, well, sir, why do we have two of these weird things? Well, one of them is a prefix, one of them is a postfix. I don't know if I should teach you, but whatever, it's a simple thing. By that, in this case, it doesn't really matter because it's the same thing. And you could have done the same thing with reverse too, right? Just to make sure everyone understands. Reverse, I mean negative. Sorry, not reverse. By negation, we could have also done this. Now, the pre and the postfix, what's so important about those is when you get these weird formulated things. But again, this was, you'll see some high languages won't even have this because it's kind of counterintuitive to have this for whatever odd reason they were trying to simplify the code. So I could have something funky like this where, pay attention here, this is going to be a bit funky. So the prefix says do it before this line, the postfix says do it after this line is completed. So let's say age, let's say age minus age times 2 plus age plus 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 4, and then multiplied by minus age. Right. Actually, not multiply. I don't want to make it too funky. I don't want to calculate so much. So let's say negate, okay? So we kind of see some weird stuff. Notice the first thing is when we do normal operators, they're separated by a space. For these increment and decrement, they actually are connected to the variable itself, right? Now, this is a postfix. This is a prefix. What it means by that is in this one line, one statement at a time. Remember, the computer goes one line at a time. It has to do this whole line, but there's a lot of stuff going on there. There's a lot of prefix, and there's a lot, well, there's one postfix and another prefix, right? So the first thing it needs to do is figure out what these variables, what is the value of it. So this is where postfix and prefix comes in. You'll probably never do this in your whole life because it's, I believe it's ugly code, and you'll see when you work, you might use it, but you probably don't know the difference. Inside this line, before this line gets executed, all your prefixes must be done. Thus the word pre. So previously, before. So age, so let's say here at age, we're going to set the value, okay? Age equals 10. So we get an easy, or let's say, yeah, 10. So the pre must be done first. So over here, the pre, we have one and then we have another. So in this pre, we're saying age needs to become 9. So this value changes to 9. And then this part gets not yet replaced, but this is changed. And we notice there's another pre here, which says age needs to go again, decrement by 1. So age becomes 8. So now this value is going to be 8. This value is going to be 8. This post value is actually not going to change. Why? Because this is post, so it's after this operation. So this is also gonna be 8. Does that make sense to everyone? Now, after you do this calculation, so 8 times 2, 16, and the rest is, okay, so 16 plus 8, 24, 24 plus 4, 28, 28 minus 8, 20. After all of this is done, so it got 20 in here, then it will go and do the plus plus. Okay, but right now you should see a little error because this is manipulating what we just have here. Let's say this is n total. So if you read this right now, what do you think the value of total is going to be, and what is the final value of age? You guys think about it while I write it down. And we're gonna run it. What is your name, Reza? Age, who cares? Notice my age is 9 and my total is 22. So let's try this out. So from 10, age becomes 9. Might have made a mistake somewhere there. And over here, age becomes 8. Then all three numbers will get replaced by 8. I'm going to put it inside of the comments so you don't lose stuff. So over here we have an 8 multiply 2 plus 8. This is post, so we don't do it yet. Plus 4 minus 8. We do the calculation. 2 times 8, 16. 16 plus 8, 24. 24 plus 4, 28. 28 minus 8, 20. Why am I getting a miscalculation? I don't know how to count somewhere. We'll think about that in a second. And the last part is after I did this calculation and I got my value 20, and over here is 22. I'll check that in a second. We then increment age to make it to 9. Right? I think I made a mistake is because one of these minuses are getting used before that. So I think here it's actually staying at 9. So it decrements it, changes to value, grabs the value, and then goes to that. Sorry, I don't use this enough times for this to memorize or anything. So anyway, let's try it again. 9 times 2, 18. 18 plus 8 gives you 26. 26 plus 4 gives you 30. 30 minus 8, yeah, 22. Okay? Any questions about this? To be honest, I shouldn't see this line ever from your code. Why? Because this is going against our first rule of our readable code, right? That thing was added back in the day to make our code smaller, but going smaller is not actually helping our code. In some cases, and like this case, this is a total mess. It's a mistake. If not now, it's a mistake to happen. It's risks that we do not want to take. Does that make sense to everyone? And if you have a question, this is the moment before I move on. And what time did you guys say you wanted your break? At 5 or 5:30?
5, sir.
5, so in 10 minutes? Okay. I'll figure this out. So we did the if statements, the switch. Let's do loops. And by the time we reach 5, we should be, after the break, we'll start doing objects and go a bit further. I hope I'm not talking too much or too fast. Again, I rely on your feedback, so if you don't say much, I don't know much, basically. And I would like it if you give me feedback on however I teach. I always like to improve, and I would never get hurt by your comments, okay? And I don't need to know about, oh, you teach good or bad. I just want to know what's your comment. Maybe put more examples. Like one of the good questions I got, which I didn't have or prepared for, was can you give us a live world example of why we would need to do implicit or explicit casting, right? So these are good stuff I would love to know about. Maybe zooming in, maybe doing this, maybe having a visual tree, and etc. And I want to get all of those out, and I rely on your comments for that. And again, if I didn't explain something correctly, you stop me and I make different examples, figure on, etc. All right. So the next thing is loops. In this case, loops is used when we have to do something more than once. This is the moment where we're going to use loops. There is really only one loop in the world, right? If you ever look at a graph demonstrating how a loop works, this is called a, what was that word? Having a blank in my head right now, I've been talking too much. I can't remember it, we'll look into it. But those little graphs, those UMLs, one second. Loop. Just doing a quick Google search. Yes, a UML loop. There we go. I'm just gonna bring that picture. So let's say, actually this is pretty good. So inside, this is pretty bad actually. I just want a clean, simple. I guess it will do. Okay. No, these are making it too complex. Okay, so in this, basically inside how your OS is built, how the computer is, it just moves data and checks everything. So as we go up in the level language, we just make that movement connection, that action for the computer more complicated, more scenarios. But in the end, it all gets translated into this simple thing where it says a question. That's what this diamond shape is. If the question is true, keep doing the action. And then ask the question again. Is it still true? Do the action, ask again, do the action, ask again. The moment the question is false, that's the moment the loop ends. Right? So in this case, we have three main loops that you should know about, or two main loops actually. The two main loops are the for loop and the while loop. Actually, let's go at the top of our page. Switch statements. Loops. When you do an action more than once. There's two major loops. We have the for loop and we have the while loop. Now, can any one of you tell me when should you use one over the other?
So we use while loop when we want a specific condition or anything like if we want age between 5 and 10, and if user enter this less than 5 or greater than 10, then while loop will run again, and it will run again until the user add age between 5 and 10.
It's a good example you gave, but you didn't mention why we would use a while loop. So even though your example is correct, your definition is wrong. Can someone else add on to the while loop?
While loop is good for validations, and for loop is good for iterating lists and arrays.
Again, you give examples, but not the meaning of why we should use one over the other. To be honest, for loop and while loop could be used for any of the stuff you guys mentioned. They're both the same thing.
So we use for loop when we know the exact number of times we want to repeat the code. And we use while when we don't know exactly, but we know the condition.
Perfect. That's basically it. Inside for loop, again, these two loops are the same thing. You could interchange them as many times as you want. Inside the bottom where it gets compiled, it's exactly the same thing. The only reason we have for loop or while loop or any other loops I'm going to show you is for us, is for our readability. It's for us to be able to read that quickly, understand what's going on, and move on. So we want to use a for loop when we know the amount of repetition And this is important, especially when you don't know how to spell. Repetition. There we go. So when we know the amount of repetition, we want to use a for loop because we know where it starts, where it ends, and how much we're incrementing, decrementing. And this is easy to read. And for a while loop is when we do not know when it would end. So in this case, like you guys were mentioning, is if we're getting users, if we're getting the users input and we need to keep doing validation. We don't know when the user is going to enter the correct data, so we keep on asking. Another good example of this would be if you're playing a game. How many times does the player want to play? You don't know. You can't foresee that. So we would use this thing, which is a while loop, creating a infinite type of loop where we don't know when it's going to end until incorrect data comes in or incorrect condition for our while statement. And the while loop actually gets divided a bit further into two things. There's the while loop, actually I'll put it inside here, and the do while. And the difference between the while loop and the do while is the do while will at least at minimum will run once. Okay, so 1 to infinity. While while loop could run 0 to infinity. So as you guys were mentioning, when you're getting the user's input, well, inside that loop, you need to ask the user to, hey, please enter a correct value, or let's say, please enter a value of, actually, let's go ahead and do it. Please enter an age between 0 to 5. Right? And each time he gets it wrong, you have to mention it again. Hey, that was not an age of whatever to whatever. Please do it again. Okay, let's do a quick example of these three things. Actually, it's 5. Just give me 5 more minutes and then I'll give you a bigger break. So let's go the first one. For the first one is the for loops. Oops, sorry, I lost a bit of my mouse. So if we type in the for loop, we need to do 3 steps in here, and these 3 steps really matter. The first step is to initialize, if there is anything to initialize. Then the condition for it to continue. Then after that, it's going to do the body, and at the end, it's going to increment or decrement or whatever it needs to do. So this is the steps for a for loop. Okay, so this is important. So, to be honest, you could leave them blank, right? So if you want, you could do something like this. And this is perfectly fine. There is no errors of any sort. But what's going to happen with this, you just create yourself a infinite loop or a bad loop, whatever loop you want to type. Okay? So this is not good. So let's go ahead and initialize a, let's say, a I. Again, I want really good variable names, so if you put I, B, C, D, it better be just for a counter, right? These are horrible namings. I would give you 0 for the whole assignment. While I is less than, let's say, 5, I afterwards increases. And if you're going to use these increments, I would like it that you use the one that's before. There's a subtle difference, which this one is actually faster than a post increment. We're not going to get into the details. You'll figure this out in the future or whatever. And then we're going to print out, I don't know, let's say, actually we had some arrays there. So this is a good thing to go through an array, like some of you said. We have this temporary array. Print out temporary array at position I. And what we could do is use the built-in, because we're a high-level language, our array actually gives us sizes and other functionalities. So we do dot, give me the length, and now we know how big our array is. We're going to go through each one of them and print it to the screen. So if we run this, skip that. What is your age? And you'll notice it's printing JSUP and a lot of spaces. Again, we didn't fill up our array. And if we make this into a print, just again, rather than print ln, you'll notice it's gonna say JSUP, and there's a few spaces here. Notice that if I scroll to the end, there's at least 3 or 4 spaces. Now, again, a for loop, while loop, do while, they're all the same. It doesn't really matter. I could have created a I here, and I could have said while I is less than temp array dot length, and inside the body of this, I would have said system dot out temp array I, and actually let's go ahead and make this a print, and this would also give me the same thing. Before I do this, let's make a system dot out. So we'll make a divider here actually. So in both cases, they're doing the same exact thing. And if you notice, the value that I get, I forgot to do something. Actually, I got an error here, and you see that this thing is never stopping. What is this error?
Increment, I think.
Yeah, I forgot to increment. So what I did is I created an infinite loop. And if this happens, if you remember, the computer is really stupid, so it wouldn't understand that this is an infinite loop. Secondly, the computer cannot stop it by itself. So if you ever put this on a server, well, you stop your server from serving anyone else. And this is one of the biggest dangerous actions you could ever do. And as you can see, I froze my IntelliJ. Again, my computer's been acting up. Just give it a second. I think it's a good time we go take a break. So this is an infinite loop. Oh, there we go. What I forgot to do was to increase the I value. And you could see it's even giving me a warning inside my IDE. If I put my mouse over it, you'll notice condition I less than temp array dot length is always true. Variable temp array is not updated inside the loop. So because this is never changed, it's always going to be less than the length. So I'm going to go at the end of this and say I plus plus. I'm going to run it again. So if you notice, both values, well, except for this, let's just make this normal space. Both values are going to show you the same value. Just this one is a bit easier on the eyes because you know by experience and so forth so on that it's going to eventually end. It initializes, checks the condition, does the body, increments. Checks the condition, do the body, increment. Check the condition, do the body, increment. Check the condition, body, increment. While this one initializes outside, checks the condition, do the body, and inside the body it also does increment, right? So really for loops and while loops, they don't have any different things. And we start getting more and more of these loops, such as you could have something called a for each. Inside this, where we have, let's say again, the temporary array. Let's go ahead and put a system.out.println that doesn't do anything. Inside this for each character, inside, this colon means inside, Java is a bit ugly. For each character inside my temp array, system.out, let's take off the println, I want you to print me that character. So this thing is called a for each. And again, notice that all three gives us the same value. All three are basically the same thing. It didn't really matter in any case. It's just what's more visible, much more readable for us, right? And this is a really important thing. Any questions? So the for each is something probably new to you, and to be honest, there's millions of these loops. And the higher the language you go, the more of these funky stuff you're gonna see. But in the end, they're all the same, and the two base of all of them is the for and the while, which is basically the same thing. So if no questions, we're gonna go on a break. You said for an hour or something. I don't know, however long you guys want. I don't really care. How long do you want your break, guys?
$20 to half hour.
Let's take 45 minutes break, sir.
That is perfectly fine with me. Actually, let's round it up to 6, okay? Have a good lunch. I gotta make food too. And at 6, we'll continue our thing, and we'll do functions and objects, and we should be good for review.
Okay.
Perfect, sir. Yeah.
See you guys at 6. If you have questions, ask it in Slack or inside this channel. Be my guest. Cheers.